My name is Rob Barnes. I'm a senior developer advocate at HashiCorp, primarily focused on the secure product line. So machine-to-machine access. In terms of that, the product that we're going to discuss today is HashiCorp Consul. Now, Consul is concerned with allowing network communication between different services and different kind of application components. A bit similar to Brian, your question earlier on about how applications are going to talk to the database, for example. So you can think of it as a service mesh. I think typically when people think about service mesh, they automatically think Kubernetes or some sort of containerized application. And that might be true for a lot of service meshes out there. But where Consul is concerned, the real value add in terms of my outlook on this is the fact that you do not need to be in a containerized environment. That's not an entry price you have to pay. It can be VMs, it could be bare metal, it could be whatever you want, right? Even managed services can be part of your service mesh, and we'll discuss that in a bit. But if we kind of look at our application again, just to kind of paint a better picture, right? So we have the profile API, which we talked about in the Vault demo, but we're introducing another API now, which is an admin API, right? And the admin API is going to need to talk to the profile API, and the profile API is going to need to talk to database, right? So here's the thing. We need to put some constraints around this, right? Only the admin API can speak to the profile API. That's kind of the rules we're setting. Nothing else in our application stack has any business talking to that profile API except for the admin API. And when we talk about our database, again, only the profile API should be talking to the database. Like nothing else should be doing that. Right? So how can we, assign identities to these applications and then control what can and cannot communicate with one another, right? So if we kind of look at how Consul deals with authorization using service identity, it's a specific byproduct of Consul, which we call Consul Connect, right? And essentially what Consul Connect does is it takes a third-party proxy like Envoy, for example, to connect all your different components. So if you look at this diagram here, we have one environment, one box, if you like, which has a web service running on it. And there's a proxy there with a console client, right? I'll explain the architecture of that in a second. And that proxy is going to talk to another proxy, which is in the other environment, which is where the database is, right? And again, there's a console client there, right? So that Envoy proxy is what's going to connect the two. Now, the thing that makes that really nice is it creates mutual TLS between the different services, right? So you now, through that TLS, you have mutual authentication between the two, and that's how we're assigning the identities. Once you've assigned those identities, now using layer 4 and layer 4 protocols, we can now define what our intentions are, right? And what we mean by that is which services are authorized to communicate with which other services. And we'll go through a really practical example of that. So just to reiterate, we have two nodes. Each of them is running the service, and each of them has a console client inside it. The way Consul works is with a server client kind of architecture. And we have Envoy proxy as well, which is the thing that's going to help us with the communication between the different services. Obviously, we have this challenge of service discovery. So everything's operating within one node. How does it know about services in another node? And this is where Consul is going to do that for us through this Envoy proxy and Consul Connect. Not only will we know about the other services, but mutual TLS allows us to authenticate these services to each other, right? So if we come back to our architecture diagram again, we're back using HashiCorp Cloud Platform in this. Actually, for my demo, we're not going to be using that for a long story sake. It was easier for me to roll my own. But essentially, we have a hosted console server in HashiCorp Cloud Platform, so we don't have to do all of our operational overhead parts of managing console. And then we have, again, same sort of setup where we have a HashiCorp virtual network and we have our own virtual network. We are running our console clients inside that, or our console agents inside that. And we have our admin API and we have our profile API, and our database is all part of that private network, right? And we have, again, the virtual network peering between the two to allow connectivity to our private subnet infrastructure, right? So in terms of how this is going to work, how is it going to authenticate the services? Well, the first step is the service is going to have to register to console, right? So this is where the client is going to take care of that. So on this node, you have a console client on there, and it's going to register whatever service it is that's running on that node. And then it reports that to the server itself. So once that happens, now what console is doing is it's saying, okay, cool, I know about this service now. Let's assign it this identity. And this is where the mutual TLS part comes in, right? So it's assigned the identities that way. So if you have different nodes, which are running their own console clients and they're reporting to the same server, now we have mutual TLS, right? And that's really cool when you're running like things like VMs or even containers or anything like that. But it gets a bit tricky if you start looking at this diagram here, because we have Azure SQL, for example, right? And Azure SQL is a managed service, right? I don't control the infrastructure per se. What I get from that is a place to store my data. That's the value of a managed service, right? How do we bring that under mesh control? So we call that stretching a mesh. And as part of console, we have a series of features that allow us to stretch our mesh in different ways, depending on what it is that we require, right? So we have an ingress gateway. So if we need to allow services from outside the mesh to talk to services inside the mesh, then we can implement an ingress gateway, right? Just pretty straightforward to do. We also have a terminating gateway, which is specifically what we're going to talk about in this part of the conversation at the moment. The terminating gateway allows us to bring things which are outside the mesh under mesh control. So in our example, we have the managed database in Azure. I can't go and install console client on that because I don't have access to the actual infrastructure itself. So what we can do is we can set up a terminating gateway and we can bring that under mesh control. And I'll show you how we do that in terms of workflow. And then we have mesh gateways. So where you have multiple different meshes, service meshes, depending on your application architecture, if you need to link two different service meshes together or two or more different service meshes together, we can then implement a mesh gateway. But more kind of focused on what we're discussing today, we'll talk about terminating gateway. So how can our applications, how can we bring the database in under mesh control with that? And again, we have two steps. So we need to register the database as an external service on our service mesh, which we can do through the API of console. We can do it through the CLI, however you choose to do that, or you can do it just through the client. And then you need to link that database to a terminating gateway. So essentially what we're going to do is on that node, we're going to run a console client with a terminating gateway on there. And we're going to link that external service that we've registered to onto that terminating gateway. So now anything within the mesh will be able to connect to that database through the mesh's proxy, right? So we'll quickly flip screen to show you in practice what this looks like and why you might roll something like this. Cool. So here we have a UI for console. Just to make my life easier, I used another tool that we have in our suite, which we're not really going to discuss today, but we have Nomad, which is a workload scheduler. It's a bit like Kubernetes, but you can run containers, you can run executables. It doesn't have to be a containerized application. It can be anything you want. It would just schedule it for you rather than you having to schedule it for yourself. It's kind of irrelevant. I just want to point that out because you can see Nomad referenced a few times, right? And essentially I'm running my application using Nomad. So if we look at the services that are registered in our service mesh console, we have the admin API, which we talked about. We have the database, which is registered as an external service using the terminating gateway. And we have the profile API as well. You can see there's a few Nomad services in there which automatically register themselves. But again, that's not really the focus of what we're discussing today. So that part you don't have to focus on. The other thing we have in there is something I've called malicious service, right? This is a service that somehow made it into our network. And it's rogue. It shouldn't be connecting to things. And we're going to have a quick look at what that means as things stand at the moment, right? So if we take a look at our database, if I click on, let's move that way. If I click on database, here you can see the network topology of database, right? So we said that the profile API is the only thing that should be talking to the database. But here's the thing, we have this rogue service called malicious service, which is able to access the database as well from a communications point of view. So that's problematic, right? If someone is using this malicious service to, pretend to be another service or to extract data from our database and so on and so forth, that's half the puzzle broken. They're able to connect to the database. And then now the challenge is to get credentials, which we talked about in the Vault section. But nonetheless, this has managed to make it inside our network, and that is bad. And we need to find a way to control which services can speak to one another. If we flip back to our services screen, we'll have a look at some of the other services. So if we look at our profile API, you can see the network topology there, right? So you can see that the admin API can speak to the profile API, and you can see that the profile API can speak to the database, right? And that's the flow that we want. However, if we configure it so that the admin API tries to talk to the database, right, that would be allowed to do it, but that's not what we intend. That's not how our application stack should be set up according to our posture. We're saying that it has no business talking to the database. That's the profile API's job, right? So how do we, firstly, make sure that that never happens? And secondly, how do we take care of this challenge of this malicious service, right? And we do that using something called console intentions. So essentially what's happened is when these services have registered themselves on the service mesh, an identity has been assigned to them, and they authenticate with each other using mutual TLS. So the admin API is saying, hey, I'm the admin API, and here's my identity using the service mesh. The profile API is saying, hey, I'm the profile API, and it's presenting its identity. And then using that mutual TLS, that firstly, the admin API knows it's talking to the right service, an imposter. And secondly, the profile API knows that it's also speaking to the right service. Again, not an imposter, right? So to configure intentions, at the moment, there are no intentions. So everything is wide open. If you're on the service mesh, you can connect to anything, and that's very high trust, and it's not the way that we want to set up our networks. I'm going to do this through the UI just because it makes my life a bit easier, but you can configure this just using config files. You can do this via the CLI or the API. But just to kind of make things a bit easier for demo purposes, I'll do it through this. So the first thing we want to do is we want to create an intention between all services, right? And we want to deny all services from speaking to each other. So, you think about a firewall rule base, it normally works from the top down. So the first thing we want to do is explicit deny all, right? So we've got all services to all services, and I'm going to hit deny, and I'm going to create that by clicking save, right? So we have that default deny. Let's go back to our network topology and let's see what difference that has made, right? So we'll go back to our profile API because this is the intended workflow. And you can see that the admin API can no longer speak to the profile API because it's denied by default. And again, the profile API cannot speak to the database. If we have a look at the database as well, we can see that not only can the profile API not speak to it, but the malicious service cannot speak to it as well, right? The only way that malicious service now will be able to speak to it is if we explicitly say that this malicious service can do that. And we would never do that in our networks. So if we want to fix this now, we've kind of broken it, but we've fixed it in a way. We've stopped services from speaking to one another, but we've also stopped the malicious service from speaking to something it shouldn't do. So now to fix that, we're going to go back and we're going to create another intention, right? So we're going to create an intention that is going to allow our admin API to speak to our profile API. Right? And we'll hit allow. There's actually different things that we can do as well. You can make it a bit more application aware. I'll just click on this just so you can see. But essentially, you can say that if a call comes into a service and there are specific things contained within the header, for example, and specific details, then it will allow that. So you can make it a bit more application aware if you want to make your applications console aware. But we're not doing that. We're going to make sure that our applications don't really know much about that. All it knows is that it's registered on a service mesh and it has to talk to other services via a proxy. So we're going to allow between the admin API and the profile API. We'll save that. And you can see it's created that rule there. If I go back to services and we go to the profile API, you can now see that it's gone from red to gray, which is green in our case. It means that communication can happen. But now the profile API can still not talk to the database, right? So we'll fix that again by creating another intention. And this time it will be the profile API, which needs to speak to database. And we will allow there. So it's created that rule there. And if we go back to our services and have a look at the database, You can see now the profile API can speak to it, but a malicious service cannot. So once you've got these identities, it's not really any good unless you can kind of use that to specify which services are allowed to communicate to one another, right? So you can think about it as a firewall in that sense there. And essentially that's what one of the key values that Consul brings to, the whole identity-driven approach to managing your network topology. There are so many other things that you can do with this. There's a byproduct of Consul, which we call Consul Terraform Sync as well. If you're familiar with Terraform, it's infrastructure as code language that allows you to, deploy infrastructure, manage infrastructure, but you can also do configurations with that. The thing that's really nice about that is you can have Consul Terraform Sync watch certain things within your Consul service mesh and react to those changes by always running a Terraform module, for example. So if we think about this in Megan's part of the talk, where she mentioned that we're in a more dynamic world where IP addresses are changing frequently on ports and so on and so forth. If you need to configure something else which is reliant on that information there, these things just change at a rate of knots. You can have Consul Terraform Sync in place where it watches for these changes and automatically runs these Terraform things. So it can configure whatever the endpoint is for that. And that pretty much takes care of the whole service-to-service part of the puzzle.
I'm someone who's frequently ranted that I get really annoyed and really tired when application developers who may not even know how their applications work try to get us to enforce application policy at the network level, going, oh, I need to protect this critical service. I need you to go ahead and like spin up a new firewall rule, and I have to, keep track of the IPs of the services running on. And it really seems like to me you just kind of got rid of that and said, no, let's secure your applications at the application and identity layer instead of trying to do something lower down the stack. And I'm extremely happy to see that, because it seems like it's such a more sensible way to do it than trying to keep track of what VM this application is running on and what file servers it needs to talk to and what what ports and protocols I need to open up, because your average application developer can't tell me what protocols they're using. I just wrote some Python code. I don't know what it does. So
it's funny you say that. So in a previous life, in my 20s, I was a network engineer. I always joke with people to say I had hair until I started that career, right? And this is one of the things.
What was
you need to give me some. This is one of the things that I found really, really challenging was, we're at the point where cloud was really taking off. Things were becoming a lot more dynamic, not anywhere near the rate of dynamism that we have right now, but it was a lot more dynamic at that point than we were used to. Normally it was, we're bringing a new service online. Okay, cool. Here's an IP address for it. And we trust that's the IP address. The attestation is, I'm Rob Barnes, and I said that that's the identity of that, right? And then it got a lot more challenging, and there were always thoughts about, are there ways that we can automate these types of things? And anytime we think about automating, it would be some sort of Python script or something that just ultimately just gave us a management overhead. And I'll never forget the day that I was told that Consul Terraform Sync was actually a thing that was going to be made. And my mind started going in so many different directions, because I was like, okay, cool. So now I don't have to spend hours doing that. I don't have to worry about this and that. It's all going to be taken care of for me. It turns out that Consul Terraform Sync has become a lot more powerful than I ever could have imagined. I'm using it for things that I didn't even know were problems, to be honest with you. We're going to talk about Boundary next. We'll discuss that in a minute. But one of the things in Boundary is we need to configure targets in Boundary. Like if you want to connect to a machine, that is a target, right? So to register a target in Boundary, I need to know the connectivity information. I need to know the IP address. I need to know the port, right? And that's okay if you're coming from the world I was in when I was in my 20s, right? It's not okay today, because, I look right now and the IP address is this, right? I look in 5 minutes time and it's something else. Not even 5 minutes. The port has changed. All these things here, right? So is Boundary really going to be viable if I can't keep that information up to date? Now, there are different ways we can do that, but before some of these features came out in Boundary, which again we'll discuss in the next one, Consul Terraform Sync was my solution. Everything is on the service mesh, right? That's the unique piece about the service mesh piece, is it has knowledge of all of your services. So it puts it in a very critical space, which is why I always think about a service mesh almost as a security tool. I know there are many network folks that don't really think about it like that, but I do, because if it's the only thing that knows about everything out there. And the way that we've set up Console, because we can now define intentions, it makes it so key. So as long as we trust the attestation of us registering the service, again, it comes back to what we talked about in Vault. How can we be sure that the service is the service? Well, it depends on what you trust. If you trust in Azure, for example, and you're using metadata from Azure, then that's your attestation, so on and so forth. But essentially, its position in the stack, it allows us to do so many things in terms of securing our network and making sure that we can actually authorize everything. We can authenticate everything. We can authorize everything. It's more than just a tagline. It's actual functionality that we can perform day to day. And I say with minimal effort, everything it gets more complicated, it gets more effort. But nonetheless, it's a lot easier than anything that you and I ever had to do in the past.
Is there any sort of thoughts of dynamic service discovery?
So it supports that as well. So essentially, if we think about, Kubernetes is probably the easiest way of doing this, right? So the console client will run as a sidecar. And as things are tearing down and spinning up, obviously new information comes, and then it will just automatically register itself to the console server. So it will update that information there. You'll find if you're ever having trouble with a service, so if you're running something on Kubernetes and maybe you've misconfigured something and it's causing it to go down and come up, go down and come up, if you stare at the console screen long enough, you'll see the blinks. You'll see it because it happens so quickly, right? Yeah, effectively it is dynamic service discovery in that sense. You just need to run the sidecar with it and then it will spin it up. In VMs, it can operate in a similar way. It's just the client that's running there. It's the same client that runs as a sidecar. So,
a quick question: how does it handle it for resources that might have been deleted or restored, and that's already been authenticated with Vault? So, you have to reestablish the connection, or does it pick it back up?
So I'm not sure I follow the question. So if
take the database as an example, you've already have a profile that's attached to the database, correct? You're authenticated, utilizing Vault, right?
Yeah.
If that database was deleted by some chance, and now I had to restore from backups, that to me is not authenticated anymore. I guess the encryption key is not valid because it's timed out. It's an old copy, however it may be. How is that handled?
So I don't know the specific answer to that question. What I can say is just in the sense of how we look at identity and how things are done very cryptographically under the hood with all of our products. The fact that you have a new database, which is in place of the old database, even though it's from a backup, something would have changed there, right? And generally speaking, with cryptography, when things are signed and things are verified, you will start to see that all of a sudden something that was verified is no longer verified, right? So it will probably need to do that. I'm going to defer to one of our console experts if anyone knows the answer to that. But my understanding of how that would work is essentially it would have to kind of re-register and re-authenticate itself because, like you say, it's not authenticated anymore. If there's anyone in there, yeah, I've got a thumbs up. So that's exactly how it would work. Yeah.
Perfect. Yeah, because I was kind of actually curious, not only on the database side, but you just mentioned Kubernetes and how it handles these things that are constantly coming in and out of it. And you think of cloud and scaling a lot of the resources.
Yeah.
Adding these and managing this is a lot of overhead. If it's done dynamically, like you mentioned, it does increase and provide a lot of value.
Yeah, it does. But that's why I said if you stare at the console screen long enough, you'll see the blinks, right? Because it is lit. And in that blink, what it's doing is it's registering itself and it's reporting back to the server. And you're essentially looking at the server. So while it looks like the service that had disappeared has just reappeared, from a single deployable unit point of view, yeah, it's the same service, but it's probably under the hood something completely different in terms of the instance of that service. But as the end user, we don't really care about that. All we know is we can trust that this platform is re-authenticating itself as a service, and whatever we see in console is we can trust. And that trust comes because we trust our target platform. If we've chosen Kubernetes, then Kubernetes is the thing that we trust, right? It's always going to be kind of that brokered, trusted platform approach.